Hi, my name is Josh Plude. I work at the UMaine Composite Center. This brief video is going to talk about the Volturnus and the UMaine Offshore Wind Program. Over the past 8 years, the Deep Sea Wind Consortium, which is a public-private partnership with a university and about 39 other partners, have been pursuing a way to harness the potentially 149 gigawatts of electricity that's waiting in the Gulf of Maine. So the image that you see here is a Volturnus 1/8, which is a scale model floating offshore wind turbine that we had in Castine, Maine over the past year and a half or so. The next graphic that you're about to see is from the National Renewable Energy Laboratory, and essentially this is a graphic showing wind speed at approximately 90 meters, so it would be a standard hub height of something like an offshore wind turbine. As you can see, Maine has uniquely high quality wind speeds. The only comparable place might be Northern California. The other added benefit about our area, though, is that there's about 55 million people that live between New York and Maine that constantly need and want more and more electricity. So if we can harness electricity that's in the Gulf of Maine and use it locally, then everyone wins. The only difficulty with harnessing the energy that far off the coast of Maine is that the water is extremely deep and the weather is not the most ideal. And so those are some design considerations that we had to overcome. Because of the water depth, we knew that a fixed base platform was not the answer, so we decided to go floating. And we looked to the vast knowledge in the oil and gas industry of different types of floating platforms. And so we looked at three in particular at the 1/50th scale. We built them at UMaine. We brought them to a facility in the Netherlands at a wave and wind basin, and we were able to test it and basically simulate how these platforms behave or perform under different wind and wave conditions. From what we learned from that, we decided to build a 1/8 scale. So this is called the Volturnus 1/8, and it's 1/8 the size of a 6 megawatt floating offshore wind turbine. We built that 1/8 scale Volturnus here at the University of Maine at the Advanced Structures and Composite Center. It's a 65-foot tall floating wind turbine prototype. And like I said, it's 1/8 the scale of a 6 megawatt, so that would be about a 450-foot rotor diameter design. It was anchored, we built it here in the lab in Orono. We put it in the Penobscot River at a Chimbro facility in Brewer, and then Maine Maritime Academy towed it down the Penobscot to Castine, Maine, in about 90 feet of water. So on June 13th in 2013, the turbine was energized and began delivering electricity through an undersea cable to the central Maine power grid. And so therefore the Volturnus 1/8 is the first ever grid-connected offshore wind turbine in the Americas. The thing that's particularly innovative about the Volturnus is that it uses a concrete semi-submersible hull and a composite tower designed to reduce both capital and operating and maintenance costs. And because it uses concrete and because Maine has such a vast experience working with concrete, we can manufacture these very locally, very easily. But essentially these platforms can be manufactured anywhere in the world where concrete and dry docks are available. So we had it in Castine for a year and a half. During that period we encountered 39 weather events between a 50-year and 500-year return period. And so that gave us a very invaluable data set to see how these units perform in something like a 500-year storm. 50 sensors were on the unit collecting data, and so we're able to use all that data and compare it to our models, and we can now confidently say we know that we can do this. So the video that's playing right now is of a major storm event that we saw that was the equivalent of a 70-foot wave in Castine. So that took place on November 1st. Even during this terrible, terrible storm, the tower only moved about 6 degrees, which is very significant. Very small, I should say, very small movement. At the end of the 18th month deployment, we had to take it out of the ocean, and so this is aerial footage of Maine Maritime Academy tugboat towing the Volturnus 1/8 across Penobscot Bay to Searsport, where we took it out of the water. Currently the Volturnus is actually at our lab here in Orono, Maine. So what's next for this project? Right now we're under contract with the U.S. Department of Energy to use all the data that we collected from this 18th month deployment to design a full-scale unit. So the contract ends at the end of 2015, and by that time we should have completed design of the full-size unit. Our overall goal is to put 2 full-scale units in the 4 to 6 megawatt range, actually in the water in 2018. So at this point, we've covered a fair amount of ground with the offshore wind program, but I wanted to try to keep this under 5 minutes as much as possible. I'm going to provide a website address here that you can learn more about the program. And if you're on the University of Maine campus or you're here for a visit, feel free to contact me, and I'd love to show you our facility. We're a 100,000 square foot lab at UMaine. Lots of great projects going on. So my contact information is here, and I'd love to hear from you. Thank you.